B-Sides Proving Ground. This is Eric Kmetz, and he's talking about cats and mice, ever-evolving attackers, and other game changers.
Hey folks, how you guys doing this afternoon? Yeah, B-Sides. All right, sweet, good stuff. You guys here for the long week like I am? I see a couple hungover people, maybe a Fed or two. You guys definitely a Fed in the back. You guys definitely want to pace yourselves because you have a couple days in store. So, all right, let's just move on. Cats and mice. Let's talk about social network bad actors. Who am I? Just to kind of start into things, I'm a long-running information security enthusiast. I've been in the BBSing, if you think HPACV, if anyone's familiar, kind of like the old BBS nomenclature for hacking, freaking, carding. I got into the internet, got into rootkitting, TCP sniffing, hijacking, sequencing, all the fun stuff that you could do around that time. And I've been going to DEF CON for quite a while. My first B-Sides was last year. I thought it would be an awesome venue to give my first talk. Moving to present, I spent a couple of years working at a social network, and in that time I saw lots and lots of abuse cases, and I kind of got outside the box and I tried to solve them. So that's where we're at right now. So what's my talk about? In the interest of your guys' time, I want to talk about what it's not about, despite the title and whatnot. We're not talking about CVEs, we're not talking about host level, network level, application level security per se. What this talk gets into is more of your eighth layer, if you will. It gets into like the user space or the political space. It's called both of these things. And so once everything else is secure, what do people do on your services, specifically social sites for the purpose of my talk? That covers spam, fraud, persona non grata. Maybe some people just don't play nice with others as per your terms of service, and they're using VPNs and Tor and all these things to access your network. And I'm going to talk about how to transcend that a little bit and fingerprint their behavior. But before I do, let's deconstruct. And I'm going to get into the way I'm going to do this is I'm going to go through kind of a deconstructive process of what you observe as a means of actually putting these systems together. So before I do, let's talk about why we care about this. Okay, it's users on a site. People are going to troll. People are going to do stuff. Well, there's a few reasons you might care. First and foremost, just as a researcher, in an academic sense, human behavior is very much a part of it. You have your security chain, and people are definitely a piece of that. So social behavior on social sites is going to transcend any other kind of service, really. Maybe you're somebody with a vested business interest. You could just be a volunteer. You might be a staffer of a site, and what you do and what you learn about it, and maybe the systems you implement could affect the bottom line, or keep it a cool place for people to hang out at least. Maybe you're just a user. You want to know what admins deal with on a regular basis, or you could just be interested. As I give this talk, I would be really curious towards the end of this what you guys think about in terms of who might be interested in this sort of thing. As I present the concepts, I'd like you guys to think about that, and maybe when we get to questions, I'd certainly like to entertain sharing that. So, people are going to abuse social sites. What can we do about it? A couple things. Manual intervention, pretty common. It's you have your admins on the site, you have your moderators. They're going to go and find trouble and deal with it on a one-by-one basis. It's pretty default. Any kind of new site, any kind of small business usually starts here. By deconstruction, we're going to talk about the pros and cons of that approach, and we're going to talk about why it might be necessary to do something a little bit better. So by doing this, we're going to deconstruct abuse. We're going to quantify it and therefore turn it into something that can be tracked, measured, compared to other methods for efficiency to see what approach is best. So part of this, after we deconstruct, is we're gonna identify our problems, and we're gonna take research. We're gonna see who solved this problem, these problems, and we're going to try to apply other people's work. We're going to harness that because a lot of people have worked on these things before, for the most part. And finally, we're going to take that research and see what's applicable and try to make it work. And in my case, some of the research I did, I found a use to take things that are primarily done with strings, and I found a way to take an algorithm and harness it for behavioral fingerprinting. And that is definitely a pivotal part of this talk. So let's talk a little bit about manual intervention. For our cases, that might be like an administrator page where, you're looking at new accounts before they're activated, before they confirm their email. Maybe you're looking at photos on a social network before anyone else can see them. You get to pre-screen a little bit. And that's, it all comes back to that default behavior. It's common. It's preemptive. Maybe you even have like a user-submitted abuse flagging system. You see that on a lot of social sites. Somebody sends you a message. You have a link to say whether this is spam, you want to block the person, and so forth. The benefit of manual intervention is that you have a human to deal with. So that's actually pretty cool because in the days of everything being like robot response, if you call a bank, if you want to get customer service and you're on a robo-dialer and you just don't even know how to get to a person, that can be frustrating as an end user. So the cool thing about manual intervention is usually, someone's going to lock your account down or take some kind of action. Maybe they'll be nice enough to talk to you first, but, you have that personal rapport. At least you're going to get an explanation of some sort. Not everyone does. So that's definitely like the upside of it. People are going to like that. The favorable outcomes can happen a lot better when you have somebody who has a little diplomacy telling you what's going on. On the downside of this, it's resource intensive. You have a site and your users are multiplying and you only have so much staff. You can only scale to so many moderators. At a certain point, you're not going to be able to give someone a human response. So that's definitely a downside because it doesn't scale. So in thinking about that, we're leveraging one of the notions of this is that these report systems, these flagging systems, we're effectively crowdsourcing. We're crowdsourcing abuse flagging essentially. So I'm going to talk about the pros and cons of that. On the downside, this is one of the most resource-intensive uses of person time. That's okay. Resource-intensive, it's a lot of resources when you have people doing stuff. Sorry. And furthermore, manual intervention can lead to very high-maintenance users. One of the things that happens is you have users that, they are happy that they got a human to handle the case, and so from then on, they're going to be your best friend, and anytime anything on the site goes wrong, you're going to hear from them, and they're going to want to talk to you for like an hour. Also, there's malicious flagging. You're going to have people that are just going, and they're mad at someone else. Some drama happens on these social properties, and they're just going to be like, I don't like this person. I'm going to flag every one of their photos, and therefore clog up your photo queue, and it's a problem. So how do we move past this? What do? We deconstruct the problem. So part of what we do is we're going to take social criteria. What aspects of a social profile are commonly manipulated for unintended uses. You join a site, you can set a profile photo, you can set a short biography about yourself, you can do comments to other people, you can do private messages to other people, you can do video chat you can do regular chat. All these things can be abused. People can take pictures, they can put IM handles or URLs across it. I mean, there's just so many ways for spammers and people to try to, lure your users to sites or even malware or phishing. So you look at these criteria and you pick a handful of it. This deconstruction approach means you kind of have some live data to work with. This is much less of your NASA planning a space landing, and you can't actively like work with the material. This is taking live data and it's analyzing it and getting intelligence from it and making a solution. So you take some criteria and you kind of classify it. You know, we're talking about strings kind of as a predominant thing. There are other things like photos, but let's just kind of stick to strings for the progression of this. And what does that do? That tells us that, let's examine strings a little closer. Like, what happens when people enter stuff into sites, and how can we process that? Well, let's stand on the shoulders of others. You know, let's go see who did academic papers, and try to see if they've solved our problems. I find that in doing this, it helps to have your problem chunked down. What are the abstract pieces of what you're trying to do? Don't bring a convoluted problem to Google and hope to find exactly what happened. Go for something succinct. What are the pieces of your problem, and how can you make them more efficient? And I'll get into some of my findings in the following slides. Finally, once we apply what we've learned, we want to measure effectiveness, accuracy, and we want to iterate on that to make it better. This is kind of like a system that you grow and learn into something better. So research. In my case, I set out to learn things about the landscape of string matching. In C and PHP, you have very basic functions like, do these strings match each other, string compare. It's a very much yes or no kind of thing for the most part. Another one that's a little more involved is the Levenstein distance. And the Levenstein distance is essentially a algorithm that tells you between two strings, how many single character edits would be required to make them identical. And that's useful. Sites use it. I've seen it in practice. But when we're dealing with matching strings that don't exactly match, Levenstein leaves a little to be desired. It's got a threshold, you can decide how similar you want to trigger on, and if you make it too open, it's going to start pulling in words that just aren't even close to what you're looking for. So Levenstein's cool, but it doesn't really cut the cake when it comes to humans that are going to adapt and try to obfuscate strings and stuff like that. So after a lot of general searching, I found a paper entitled A Comparison of Personal Name Matching, Techniques and Practical Issues. I only have time to present just a little bit of it, but the gist of it is that somebody set out to try to normalize and consolidate patient records in the medical space. And, you might have Robert M. Smith or just Bob Smith, and, how do you decide that that's a single patient based off of a name? And so the paper goes on about several different string algorithms. There's some pretty cool ones out there, including Levenstein edit length, but what they do is they don't just take any one string algorithm. They take Levenstein edit length, longest common subsequence, Jarrow-Winkler composite, dice coefficient, a couple others, and they take the root mean square of all these different thresholds, and they even do a phonetic component with SoundX. And they take the root mean square of this, and across all those algorithms, then they decide across a master composite threshold, are these the same name? And that's effective. That's a multi-layered approach. It works a lot better than any one alone. So after reading this, I was inspired in two ways. First of all, the multi-layered thing really hit me hard. I was like, well, why don't we build multiple systems for everything that looks at a lot of stuff? It's fault tolerant, it handles variations better. Sometimes no one or two ways of looking at something are going to solve what you want. It's going to solve what you want and bring in too many things that you don't want. So the other inspiration I had about this was longest common subsequences in particular was a very interesting string algorithm for me. I thought it was just like perfect for a lot of applications we have in strings, and I found out a little more about it. So spammers love to obfuscate strings. It makes our problem matching them harder, and again, that comes back to why I like longest common subsequence. Luckily for us, there's a lot of works and papers, so in this particular deconstruction problem scenario, we're lucky. Whatever problems you're trying to solve, you might not be that lucky, but again, abstracting your research out, putting it in small pieces, that'll help with that. All right, so I have a slide here, and this is just a couple examples in collage form of longest common subsequences. If you can see the lower left and upper right corner, that's just your basic source code and file diffs. On the lower left, you have some PHP code. Upper right, you just have some basic text files. And the point is, if you've ever done a diff on a file, you've used longest common subsequences. In the lower right-hand corner, you can see just some genetic sequencing. It's used for that. And on the upper leftmost corner, this is my favorite part about it, and it illustrates an important point. You take two sequences, and longest common subsequence will advance both of them, but it will also not care if there's noise in the sequence. So if you're looking for a particular set of actions that occur in order, a set of strings, whatever, it's really great for matching stuff that there's noise in. It's kind of fault tolerant that way. It's a good thing for dealing with string parsing and other things. So we already know it works well for strings, but wait, there's more. I had an aha moment where I thought long and hard about longest common subsequences, and I sort of said to myself, well, okay, that's cool, but like, it could actually be used for other things. It's already used for letters and words. Well, what if you took behavior and you just represented it by a letter or a word? I just signed up for a site, that's S. I just filled out my profile, that's P. I uploaded a photo, that's U. I just wrote someone, that's M. Right, so you kind of can store in a database or memory these words or these letters about people's actions. And then suddenly, if you're trying to, match things, you're not matching spam words against written text. You're actually matching behaviors against signatures of behaviors that might be of interest to you. Furthermore, it might not even be behavior. It could be an attribute. Maybe if there's an N in there, we know that they came from a certain net block, right? So it sets up the field for signatures of behaviors and attributes of users on your sites. Most of you are probably familiar with the saying, actions have consequences. I propose to you that actions have sequences. Multiple actions in a behavior have common subsequences. This isn't an end-all solution. Kind of drawing from that paper again, it's best deployed in layers. Just like the string matching layers, this is very well deployed in a combination approach. String algorithms by itself is not going to do everything you need. Behavioral fingerprinting by itself, it's not going to do everything you need. They're better when combined, but legitimate users can still false negative, by doing any of these behaviors that people normally do on a social site. And that's really the challenge. It's like, how do you differentiate legitimate users from people that are not legitimate? Well, how you do it is, in my experience, is synergies of layers. You might have criteria that by itself is not at all useful in differentiating a legitimate user from a fake user. This person's from the US, this person's from the Philippines. Oh, well, that doesn't really, what does that tell us? There's legitimate users from both countries. Well, this user signs up as a female and they message 20 people within 5 minutes of signing up, and they're also from the Philippines, and none of our other users from the Philippines do that. Or, there's better examples, but basically in the synergies of these examples and the mutually inclusive behavioral patterns, you'll find the differentiator into whether these are accurate checks or not. And in the mutually exclusive joining of them, you can clear people and avoid even scrutinizing their account that much, because you know that they completely for sure don't match whatever pattern you're trying to apply to them. And that all gets into inliers and outliers. Again, this is a close examination on a per criterion basis. What do common users exhibit, and common abusers exhibit, and what do common legitimate users exhibit? So you take that approach, and then you kind of start applying them in pairs, and you see what pairs of 2 and 3 things, maybe even more, work to your advantage, and that will really help you with accuracy. System integrity and efficiency. Some of these codes, some of these tests, once you put them into code, they're going to loop in the wrong users at first. They kind of just will. That's part of the process of this. As long as your system isn't automatically processing these people, then it's not really a big deal, actually. It's kind of good because everyone that loops in is a learning case for you to examine them and create more rules and distinctions about whether these users are legitimate or not. And then you iterate on that, and every version of your system after the next is supposed to be better than the last. But why settle for just a really refined system that can match most attackers? Why don't we confuse and frustrate them too? And first of all, we have to understand attackers evolve, so what do all of us do, especially with a hacker mindset? When we encounter a barrier online in our computer, we try and get around it. How do we do that? Well, we look at what stopped us and we adapt and we try again, and it's very much it's a pretty common thing for all computer use. Well, attackers do the same thing. So what we want to do is kind of make our system low feedback. You don't want them to understand why or how we're triggering them. And the social sites need to understand that and evolve in much the same way. Your current attackers already have intelligence on your systems. Your past ones most definitely have intelligence. Your new attackers might benefit with that intelligence. They might bring a whole new bag of tools to the plate. But if you provide very low feedback, that's going to help you in all these cases. And what you really want to do, the point here is to use pre-existing intelligence in whatever you make, and take examples from what you've seen. So countermeasures. I have had great success with asynchronous response. On top of it, it makes it very frustrating for the attacker to adapt to. It enables the sense of a permeable barrier. These people kind of get caught on your checks, but you don't immediately act on them. And what does that do for us? It helps us collect intelligence on them as they're still in our system. At some point, they're going to get booted out or processed, whatever you do with these users. But before they do, we get to understand them better. And what does that do for us? Well, it makes it so we can take that intelligence and we can go take our checks that caught them, and we can look at more and new criteria that we might not have thought of in the first place, and we can write those checks for them too. And so what I find is when you have this, when you can catch the same type of abuse 3 or 4 times over, then you're pretty well calibrated. Especially with a synchronous response. It's going to be enormously frustrating to attack your system. It's not going to pay off very well. It's going to be difficult, and they'll probably look for an easier site. What would a system like this look like? An example might be a system that recognizes a phrase, a photo, a net block combination, a behavioral signature, time between actions, time from action to action, and the point of that is that we get to scrutinize behavior further, and kind of I touched on that. So basically, iteration. Cool. Wait, what? The takeaways on this are hopefully this helped you guys understand a framework for dealing with this type of problem in a deconstructive way, and leveraging intelligence to help. Another thing is think outside the box. I can guarantee whoever's messing with your sites is doing just that. It's a war, not a battle. Don't get discouraged if your site's getting just pummeled. You're going to learn something from it. You can harness that for other stuff. And finally, have fun with this. If you work on a site that has a lot of traffic, you're going to have a lot of chances to collect a lot of data, but don't let that data go to waste. Don't just handle users and move on to whatever you're doing or move on to the next one. Store that. Remember who your people are. Remember their techniques, tactics, and practices, because that's how you'll recognize them next time around. And that's pretty much it. I'd like to entertain questions, comments, any thoughts that this might have provoked. If not, I'll be around. Feel free to contact me. I'm happy to talk about this stuff. I'd like nothing better than some of the ideas I laid out here to be taken and applied to some of your industries and maybe even pivoted to something completely different. Thanks for your time.